Yeah, thanks, Russell. And thanks, Dave, for a great introduction for the MinEx CRC. So I'm going to be talking to you about some of the, I guess, pre-drilling phase activities that we've been doing in the New South Wales survey. And I guess a couple of disclaimers. I'm giving this talk on behalf of a lot of people, both current and recently departed the survey, but also a lot of the work that's happened with our collaborators at the various research institutions and other government agencies. And also, a lot of these sort of individual work packages I'll be talking about could constitute their own presentation at a conference like this, but I'm going to try and give you a bit of a highlight about what's been happening, and hopefully that'll give you a bit of a taster, and if you want to follow that up, you can with the various people and references that's in this talk. So yeah, I'd like to acknowledge the various MinEx research partners and industry participants that we've been working with and collaborating, and also with KenX, and you heard a bit about what KenX did, or our collaboration with them from Ariane yesterday. I'd like to acknowledge we're speaking to you on the lands of the Wiradjuri people, and I pay my respects to their elders past, present and emerging, but also our other MinEx areas around the state, and I acknowledge the various Indigenous Aboriginal people in those areas that we're working in. Okay, so the MinEx areas that we're focusing on, or the areas that we're focusing on under the MinEx project in New South Wales, they've changed a little bit. We've had a bit of a refocus, a bit of a pivoting over the last couple of years, a bit of a combination of different areas, but they're generally in three main areas of New South Wales, and they're all these undercover extensions of known mineralized terrains or known fertile belts that's been mentioned in a couple of sessions at this conference. So we've got Mundy to the west, so that's the undercover extensions of the prospective Broken Hill rocks there. We've got the Cobar Basin, and then we've got the Forbes-Dubbo region, which encompasses a lot of the Macquarie Arc that a lot of the talks on the first day were talking about. We're targeting areas where the depth to basement or cover thickness is shallow, so it's definitely under 500 meters and often a lot less than this, under 100 meters in many regions. And we're sort of starting the phase 2 of the 10-year program of MinEx, and the work to this date has really been gathering data in the pre-drilling phase, and we're starting to incorporate this and integrate that to come up with a drilling program that will hopefully be starting, as Dave said, in the Cobar region next year. So I'm going to talk to you a lot about Cobar in this talk because that's our sort of initial main focus of our MinEx CRC work. So I don't need to tell you a lot about Cobar. It's been a world-class precious and base metal mineral province for over 150 years. But as we all know, we need to discover new mining to extend the mine life. A lot of the exploration activity, and you can see there from the tenements that were current just before MinEx started in this region, in the green there, were really focused around those areas of outcrop, so the outcropping parts of the basin. And the real target is to move those exploration activity and data acquisition and synthesis into those more undercover areas to the north and the south. So thanks to Joel, he went through the main mineral systems in the Cobar Basin. Just to remind you, we generally have two main groups: that earlier high temperature magmatic phase, which are concentrating the copper gold type deposits, and that later non-magmatic orogenic phase, mostly containing those lead zinc silver type deposits. Ariane gave a really good talk yesterday on the mineral potential mapping work that she was involved with at KenX in the Macquarie Arc. There was also an equivalent mineral potential mapping piece of work done in the Cobar Basin, and here's two of those mineral systems that were looked at, the copper gold and lead zinc. But like Ariane said, this used the weights of evidence approach, and obviously the areas that were coming up as prospective or highly prospective were generally in areas where we had a lot of data richness. So those are those blues, prospective to red, highly prospective areas there. And it's really in those areas that are bounded by those red boxes on the screen there that we wanted to go, okay, well, why are these areas coming up as slightly less prospective or unprospective? Is it because there's something different about the geology, or is it simply because there's just less data richness in there? So we'll come back to that concept in a second with some follow-up work. A lot of the focus of the high logger activity down at Londonderry over the last few years has been on acquisition of new spectral data from drill core, legacy drill core held in the core library, and from company core that's been generously donated, at least either short-term to be scanned or long-term in the core library. So we've now got over 100 drill holes in that Cobar Basin region that have been scanned, and about 60 to 70 of those have been in the last sort of 2 to 3 years. The key scanning campaigns have been both focused on the major prospects and historical and current working mines in the area, and also to get a more regional picture of that sort of regional coverage of drill holes. There's been some scanning of those areas as well. All that data is available in MinView or on the Ozscope NVCL portal. So one of the first major acquisition campaigns we did was a large Aem survey across the Cobar region there, and you can see those are the black lines, the flight lines that were acquired, so between 2.5 and 5 k's apart, so quite a regional survey. I guess from Dave's analogy, that would be getting you on the golf course or on the fairway. There was also some infill that was done by industry, and those are the more tighter spaced pink lines there. All that data is now publicly available, MinView and GA's portal, and we've also released a recent interpretation package, a report and associated data package a couple of months ago, and again that's available on or through DIGS. So I'll run you through some of the I guess key or group of interpretations that we did and is available through that report and data package. Obviously one of the first things, or the most great ways you can use that data in conjunction with other things such as drill hole data, high logging, is to map those key interfaces, so knowing where you are in the stratigraphy, things like depth of transported cover, depth to fresh basement, and when you look at the images such as that on the ground, combined with what we're seeing in drill holes, it's pretty common for a large part of that Cobar region to have a thin transported Cenozoic cover, and then you have a variably thick weathered or saprolite zone there, a few tens of meters, and then often it's actually quite a sharp contact or transition into that more fresher basement there. So we use both what we see in the field, from drill logs, high logger data to help us constrain and inform those interpretations using the Aem connectivity sections. Where there is a good conductivity contrast between areas of groundwater or zones of groundwater and the host country rock, we're able to really map out or confirm if there's an existing interpretation or other data of potential water resources. So in this case, paleo channels that have been imaged and picked up through both geophysical imagery but also confirmed with drilling. And again, we can use that to both confirm what we're seeing in the AEM, but also extrapolate away to those other lines to potentially look at areas that are important for groundwater in the region. As part of the interpretation process, we were also able to look at those, I guess, deeper connectivity anomalies, those more isolated connectivity anomalies. Now, interpretation of AEM it can be quite a complex process. There can be competing variables that can produce the same the same features. So for example, with deeper conductors, they can be produced not just from geological features, but from things like anthropogenic infrastructure, power lines, train lines, things like that. So we tried, when we were doing the interpretation process, we were trying to eliminate those anthropogenic events to really focus on potential more conductive areas and targets that may warrant further follow-up, more closely spaced geophysics, or even drill testing in the future. So again, that's available in that data package. And what's recently actually been released on MinView as of, I think, 2 or 3 days ago is some more detailed 3D modeling packages from the northern and southern parts of the Cobar Basin, incorporating both that AEM interpretation of those key surfaces, but also using drill hole data, cross-sections, things like, or existing cross-sections and things like that, to produce features such as this in 3D, Leapfrog and GoCAD packages that you can download, which give you those key, or those updated, I guess, key interface depths, like depth of cover, depth of weathering, or depth of fresh basement. So another major acquisition program we did was a water bore sampling campaign, or hydrogeochemical analyses, and this was done in collaboration with CSIRO. There was a sort of a regional data acquisition program where we analysed almost 90 water bores for the full suite of trace elements through the isotopic analysis at them, and it even also looked at things like hydrochronology to look at the age or the residence times of waters in the region, and that was very interesting as it told us that there were some groundwaters that had been in the ground for up to 18,000 years, all the way down to much younger, less than 100 years of residence time in the ground. Again, there's a comprehensive interpretation report driven by CSIRO there. But in this area, what was quite interesting was looking at the different indices that can be used to, I guess, predict the, find the, in this case, gold-related Cobar-type deposits, and this highlighted some potentially new areas that that were anomalous to background, which may require a bit of further follow-up. There were 3 main areas there in terms of that elevated base metal and other elemental concentrations. I'll just point you to area B at the moment, because we'll come back to that in a second. Another package of work that's been really interesting, I think, is by Hamed Zakri, who's here at this conference, and he's been an embedded researcher with us for the last about 18 months or so. He's currently based at UNSW. But what he's done is to look at a combination of both spectral data from HiLogger and PXRF from drill holes in the Cobar region that contain cover sequences all the way down through to partially weathered and fresh basement. Obviously, from the HiLogger, it's pretty easy to pick where you are transitioning between cover, weathered basement, fresh basement. What Harman's done is to have a look at the chemistry, so PXRF, and he's diligently analysed a lot of core chips with XRF and drill core, and run that through CSIRO's data mosaic program to have a look at where the chemistry is telling us we're getting those major boundaries. And to a large degree, that's, if you look at the that middle image there, if you move to the right, that's where the more higher order or more important boundaries are in that data mosaic program, and they match up pretty well. But what Harman's done, he's taken that a step further, and he's gone, okay, what actually are the elements in the PXRF that are actually controlling those changes in those different interfaces the most strongly? And he's done that for a few drill holes and managed to use machine learning, supervised classification to really identify which of those elements are most important. And that's got some pretty important implications for the use of maybe near real-time information to tell us when we are, to orient us where we are in the stratigraphy, but but also when we're going to be changing into the next layer. So that's a lot easier to tell us. It's easier to use a PXRF to tell us where we are in the stratigraphy than trying to wheel up a high logger. We've also had a researcher at the University of Newcastle last year doing some sedimentary provenance work and some sedimentary geochemical work to elucidate or give some more detail to the sediment sources that are producing the fill in the Cobalt Basin. This is work by Bo Yang, and he's got a paper in preparation, I think in the AJES. So he's looked at the tidal zircon geochronology, uranium-lead work to identify the two major sources of sediments in the Cobalt Basin. An older sequence of material coming from the Canberra Ordovician basement, so that Adaminaby and Girolambone group that Joel talked about yesterday, and a younger magmatic component, so from those intrusive rocks largely to the south and the east. And we know in the Cobalt Basin that mineralization is both structurally and stratigraphically controlled, and some of the preliminary work that Bo's been doing has been showing that we're getting a difference in the type of detritus that's being shed into the basin over time. So we're getting more material from those older Canberra Ordovician sources as the basin filled, and that would be going from that sort of the lower to the upper amphitheater group in the Cobalt Basin. But also a bit of a structural control on mixing of sediments between the northern and southern parts of the basin. So that gives us a bit of insight into the spatio-temporal evolution of that Cobalt Basin. Also, he's been looking at some sedimentary geochemical work, and what's really interesting here in terms of potential uses for mineral systems is that he's identified some differences between the mineral hosting formations, such as the lower amphitheater group, from the mineral barren formations from the upper amphitheater group. And it's often quite hard to distinguish these two in the field and their sort of visual or physical characteristics. So using some chemical discriminants may be quite useful in this regard for a mineral systems approach. So one of the aims of, I guess, MinEx in this area, but for the Cobalt Basin in general, as I said, was to extend the interest or the exploration to those areas that are undercover, extensions of the mineralized or the known mineralized areas of the Cobalt Basin. So here's a tenement map, tidal map, just as MinEx started. That map there shows all the similar to what Dave showed in Northern Territory, all the land that was taken up during or has been taken up during MinEx or applied applications, and that's the current state of play there. So I guess it really has shown that there has been an increase in interest and investment in those undercover areas, which is exactly what the goal of MinEx and the goal of a lot of what the survey is doing is trying to promote and collaborate with industry on. So some more specific examples of how the data has been used and is being actively used would be that area B that showed up elevated moly and antimony in that southern part of the Cobalt Basin. There was also a coincident lead and soil anomaly in that area, and AGC has been actively drilling and looking at this area and producing some good results there to identify a base metal sulfide zone, and I'll refer you to those ASX announcements for further information there. Of course, it's not only mineral resources that are important in this region, it's groundwater or water resources to support both mining activities, agriculture, and support drinking water, for example. And some drilling by Peel near their Whirlong prospect have shown they've got the locations of drill holes which are getting good flow rates from water bores correlate with what we're seeing in both the magnetics there, with an interpreted paleo channel, but also in the AEM, which shows potentially areas with higher resistivity, so the more blue areas there that will potentially be hosting more fresher groundwater in the area. So going back to that mineral potential mapping, if we look at the image on the right there, where we've got the work that Kennex did in the area, you can see that in the north and the south there was a fairly low mineral potential prospectivity. However, some recent work done by the University of Newcastle groups there have used a more of a random forest approach, similar to what Ariane was talking about yesterday. And they've shown in those northern and southern areas there, using more of the geophysics, so incorporating AEM, MT, things like that, other geophysical data sets, that we're really seeing a perhaps enhanced prospectivity in that region, potential prospectivity that may help us to target areas to test and to do some follow-up work on. So quickly moving across to a couple of slides on the Mundy region. This is in the west of the state. We're trying to test the undercover extensions of those mineralizing systems, the broken hill types, and things like IOCGs and MVTs in the area. It's covered under the Mundy Plain by Mesozoic to Cenozoic sediments. But also there's a very interesting conductor called the Konomona conductor that's been imaged in MT by a group in South Australia, and it's actually at its shallowest underneath the Mundy Plain there to the north of that focus area, and the top of it is probably only a few hundred meters in depth. So very interesting to potentially test what's producing this feature. We've also done, or recently acquired, another Aem survey over that region, again 2.5 to 5 Ks. That data is available to download and view in MinView, and I'll just give you a little snapshot of some interpretations so far. So let's zoom in on this area. So the edge of this, you can see this is from the CMUS geology. To the left is where we've got that covered region of the Mundy Plain, and there's quite a sharp contrast there with outcropping rocks, and that's the Mundy fault there. And we had a seismic line that was ran through that area, and you can see that dip of what's in the AEM, that dip of the conductor is coincident with what we think is the dip or the image of the Mundy fault in the seismics there. Ongoing interpretation is happening. We're using things like drill hole picks, interpreted cross sections there to help us to put those key interfaces on and hopefully to build up a similar type model that we did in Cobar. Coming across to this area of the world, the Forbes-Dubbo focus area, we've already acquired some water bore samples there, and there's been some preliminary work to show there's been elevated things like gold and platinum concentrations in various areas. Again, the data is available on MinView, the raw data, and the interpretive report's coming very soon. And we've just announced a proposed Aem survey in the region there. It'll have a nominal 2.5 K line spacing, and acquisition hopefully will happen in the second half or later in this year. Other work that's been done by researchers in the region, this is Cam Adams. He was again a postdoc researcher out of Newcastle working with Bob Musgrave to update the petrophysics, rock properties of some of the major important rock units in the Macquarie Arc. So he's done a bit of a legacy study, as well as acquiring new data, both MagSus, density, and chemistry, to help us really classify some of the major important rocks in the Macquarie Arc. And again, results, data, interpretation coming very soon. I guess one of the really important and beneficial aspects of MinEx from not just my point of view, from the survey's point of view, is the collaboration between industry, academic researchers and geological surveys. And you can see just a flavour of other MinEx research projects in New South Wales. You've had a great talk from Joe Schifano there, but there's also things going on in terms of biogeochemistry, petrophysics. So Jim Austin and Andreas, new PhD student, but also some I guess, cutting-edge copper and sulfur isotope studies, as well as ultrafines in the Cobar Basin with Ryan Noble at the CSIRO. So how can you access this data? Well, a lot of it's available in MinView, online portal, and viewer. You can download lots of data in there. DIGS, the online repository system, that contains all of our reports and data packages, and also the our survey MinEx webpage, which gets updated when new data is available and updates. All right, I think that's my time to leave it there.